Okay, in this video we're going to continue our discussion of multi-level binary logistic regression using the example provided in Chapter 4 of Heck et al.'s book, Multi-Level Modeling of Categorical Outcomes, and the dataset was downloaded from this website here. So in our previous video we tested an unconditional model where we were looking at essentially modeling between school variation in the proportion of students who are identified as being reading proficient. So the data set that we have right here, the level 1 outcome variable is reading proficiency, which is coded 0 for non-proficient and 1 for proficient. So this is basically a student level or level 1 outcome variable, and those students are nested within different schools. So in this video, rather than just looking at between school variation in proportion of students identified as being reading proficient, we're going to now model fixed level 1 predictors of students' identification as being reading proficient or not reading proficient. So the level 1 predictors in the model will include a variable that's called low SES, which is coded 0 for not low SES and 1 for low SES. Female, which is coded 0 for male and 1 for female, and then minority status, which is coded 0 for non-minority and 1 for minority status. So to run our analysis, we're going to go to Analyze, Mixed Models, and Generalize Linear. Now I've kind of reset this already from the previous video, so I'll kind of re-demonstrate a few steps in here while adding in our fixed predictors. So the first step in this process is we're going to move the level 2 identifier variable over to the subjects box, and so you can see it highlights right here. Next we'll click on Fields and Effects and then use Custom Target, and then we're going to select the reading proficiency variable, which is again coded 0 and 1, and notice that it is being recognized by the program as a nominal variable. You'll also see that the level 1 predictors, low SES, female, and minority status are all also being treated as nominal variables. So I'm going to click on reading proficiency here, and by virtue of the program's recognition of the scale of measurement, that impacts which target distribution and link functions are given as options. So in this case, you can see that binary logistic regression highlights as well as a couple of other options. So we're going to click on that and then go to Fixed Effects. Now, we already have the default intercept, which is basically going to reflect the grand mean across schools of the proportion of students who are identified as reading proficient. But we're also going to include several our level 1 fixed predictors, which is low SES. So we're going to move this over here to the main. We'll do the same for female, and then we'll do the same for the minority variable. So now when we interpret the intercept, we are essentially adjusting that for the presence of our predictors in the model. Next, we'll click on Random Effects and click on Add Block. And when we do this, we're going to want to be sure to include intercept, because we're going to still allow for there to be between group variation in the intercepts, which again, the intercepts are basically reflecting the proportion of students associated with the different schools. So that's the basic idea. Now keep in mind too, I haven't really brought this out yet, but the intercepts are scaled in the form of log odds. So we'll talk a little bit more about that when we start looking at the output. Next, we'll go to Subject Combination, select School Code, and then we'll leave the Random Effect Covariance type as it is. Under Build Options, you'll see it says Sorting Order for categorical targets and categorical predictors. So what this does is it impacts how which group on your nominal or ordinal variables are going to be treated as a reference or baseline group, and which one's going to be treated as a target group. So when it's set as ascending, then basically in our data set we have two groups for those variables, basically group coded 0, group coded 1. So if it's left as ascending, then it's going to treat the group that is coded 1 as the baseline or reference category and the group coded 0 as the target group. And I personally prefer just to treat the baseline group as the one that is coded 0 and the target group as 1. That's just my personal preference. It doesn't make any real difference. It doesn't make any difference really mathematically, but it's just the way I tend to think about it. So I'm going to select descending for both of these. For tests of fixed effects and coefficients, just kind of staying true to the presentation in the textbook, I'm going to use the robust estimation to handle violations of model assumptions. All right, so let's run the analysis. So I'm going to click on Run, and there you go. So you'll notice, first off, when you're looking at the model summary, you can see the target variable is reading proficiency, probability distribution is binomial, link function is logit. So all that was, what we had selected early on. We also have, a couple of fit indices right here, the Kaikis and Bayesian information criteria. When we scroll down and look at the classification table, this is basically giving us the proportion of cases that were correctly predicted to fall into one or the other outcome groups. So you have to kind of think about it as, this is what is observed in the data in terms of the proportion of the sample that falls into the reading proficient versus non-reading proficient group, and then what percentage of the sample were correctly predicted by the model to fall into those categories. So the overall percent correct in terms of classification accuracy was about 72.5%. When we scroll down and look at the fixed coefficients table, we have the regression coefficients right here, and we are interpreting these in terms of log odds. So basically, you have to kind of think about it as we're not the actual metric is not in the form of probabilities or likelihood of falling into the target group, which is the reading proficient group, as opposed to the non-target group. Rather, it's the log odds associated with target group membership. So, and to get at that kind of notion, we sort of have to operate through the vehicle of odds. And basically with odds, you can think about it as a ratio of probability. So the probability of falling into group A as opposed to the probability of falling into group B, assuming that these are two mutually exclusive outcomes. So you can see the ratio right here. So if you have an odds that is greater than 1, that would indicate that the probability of falling into group A is greater than B. If it's less than 1, then you can see that the probability of falling in A is less than B, or you could say that the probability of B is falling in is greater than A. If odds is equal to 1, that means that basically you have an equal probability of falling into either of the groups. So over here, these coefficients here are referred to as odds ratios, and essentially they reflect, with respect to the predictor variables, they reflect the change in the multiplicative change in the odds of falling into the target group for every 1 unit increase on the predictor. So that's kind of the way to think about it. So if you are looking at the coefficients here, you're essentially talking in terms of, we can say that, well, the log odds are changing a certain amount for every 1 unit increase on a predictor. So at any rate, let's look at our output more closely. So you can see right here, you'll notice that you've got low SES is equal to 1, equal to 0. And you'll notice that you've got a little 0 right here with a little b superscript. And that's just referring to the notion that these are essentially redundant parameters. And essentially what's going on is the program is treating each of these variables right here as dummy variables. And so so you can see that the equals 1, this is essentially reflecting a difference in the log odds between groups, between the low SES and non-low SES groups, between the males and females, and between the minority status and the non-minority status groups. So, and this, the way the output is printed out is because the program is treating the SES, female, and minority variables as factors. So it will look a little bit different if you were to treat them as scale variables, which is perfectly permissible with the dummy variable. So, and I'll just kind of show you that briefly in a second. So, at any rate, so when you're looking at this difference right here, like I said, it's in the form of log odds, but you could roughly interpret this negative value right here, given the coding of low SES being 0, low SES being 1, and given that we have a negative coefficient, that would basically indicate that a person who was identified as being low in SES was less likely to fall into the reading proficient group. So there's that negative coefficient here. And that the relationship between the low SES variable and reading proficiency was statistically significant in the model. And then also, if you look at the odds ratio right here, you can see it's actually less than 1, which is essentially indicating that once again that the students identified as low in SES were less likely to be identified as reading proficient than the non-low SES students. When you look at the female predictor, you can see it's positive, and basically males were coded 0 and females were coded 1. So that tells us that essentially females were predicted to have a greater likelihood of falling into the reading proficient group as opposed to the non-reading proficient group. And that predictor was also statistically significant in the model. You can also see that the odds ratio was greater than 1, which is actually telling us, that again, the females were the likelihood associated with falling into the reading proficiency group. Basically, females were 1.6 times exhibited a 1.6 times greater likelihood of falling into the reading proficient group than the males. Then when we look at minority status, you can see we have a negative coefficient here, and this value is less than 1. And what that's telling us is that basically students, again, thinking about the coding of 0 being non-minority and 1 being minority, the negative coefficient and this value being less than 1 is indicating that students who were identified as being of a minority status were less likely to be also identified as being reading proficient. So that's essentially the way that you can think about this, and also that predictor was statistically significant in the model. So our 3 level 1 predictors were all significant in looking or predicting reading proficiency. So once again, just as a summarization of this, students who were identified as low in SES were less likely to be deemed as reading proficient. Females were more likely to be reading proficient than males, and then students who were identified as falling into a minority category were less likely to be identified as being reading proficient. And when we scroll down and we look at the random effects, in the last video I mentioned this, but I'll reiterate it, that in terms of level 1 residuals, you can see right here that essentially there's no test because our level 1 variable, or level 1 outcome variable, is not continuous. So there's no test of significance in terms of the residuals at level 1. But we do have the random effects test in terms of the variation across the schools in terms of the intercepts, or basically essentially reflecting proportions of students being identified as falling into the reading proficient category. And so you can see right here that the variance estimate is also deemed as statistically significant. Once again, I do want to kind of reiterate that the intercept, variation in the intercept is not actually of the proportions themselves, but rather the log odds that we were talking about up here. and essentially the log odds is conveying information about proportions and likelihood. So I do want to just kind of re-highlight that particular issue. So at any rate, let me just kind of give you one final detail. We had low SES, female, and minority were all treated as factors in the model. And let's just see what it looks like if we treat these as scale variables. And like I said, we could have entered these variables as scale variables into the model because they're all dummy variables with two categories. And so it would be perfectly permissible to include them in this kind of fashion. So if we do this, and I'm just going to go back and look at our effects, make sure they're all lined up. Okay, so we have the program's adjusted and everything. So I'll run it again, and it doesn't have any impact on the model or anything like that. But now you can see that over here you've got the coefficients. These are exactly the same as what we had seen above. The significance levels are all the same. The odds ratios are all the same, and so forth. So it just looks a little bit different because when the program treats those variables as factors, you get this sort of comment about a parameter being redundant, and so not being estimated. So that's just a little FYI for you moving forward. So that covers this particular video looking at um, fixed level 1 predictors in our multi-level binary logistic regression.